So let's start the chapter number 15, probability. That is the last chapter of grade 10 mathematics. You have already studied this chapter in grade 9 already. We are repeating one more time. There are few more concepts this year, few different kind of questions that we are going to discuss. So let's start first of all with the meaning of the probability itself. Probability is about chances, right? Either you can win a game or either you can lose the game, right? It's all about that. What are the chances? We talk about what are the chances of winning this match, right? Cricket, 50%, 60%, 90%, 99%, right? Okay, but probability is not assurance about getting that chance, right? If an event or particular situation has probability of say 99% and another like not happening, right, or losing, that is 1%, it doesn't mean that event situation with the 99% probability is going to happen. No, it's no surety of that. Sometimes it happens that we say that 1 in a million, 1 in a billion, right? So you think of the probability 1 out of billion, right? So 1 out of 100 crore people, that's like very difficult thing to do, right? It doesn't mean that it doesn't exist. Less probability, it doesn't mean that it is not going to happen, and more probability, it doesn't mean that it is surely going to happen. It's just about an idea that is it going to happen, but up to what extent, what are the likeliness, what are the chances that it is going to happen, and what are the chances that it is not going to happen. So let's discuss few terminologies, few terms related to this chapter that will be helpful to understand this chapter in the better way. So first, it's self-probability. So it is a measure of chance of occurrence of an event, right? We want to measure that how likely this event is going to occur or happen in the real life. So what is the event? Okay, collection of some outcomes of an experiment. Okay, let's say you are performing an experiment. Again, what is the experiment? Okay, it's here. Operation which produce some well-defined outcomes, right? Let's talk about snakes and ladders or Ludo, right? You must have played it. We use die there, right? Now you throw a die and you get some number and your player moves according to that, right? Now let's talk about that die. Now, is it going to happen in that die? If you throw a die, you are going to get number 8. No, it's not going to happen. Is it going to happen that you are going to get 0? No, it's not going to happen. The outcomes are defined like 1, 2, 3, 4, 5 and 6. It's already defined that any of this number will surely come, no less, no more, right? So that is called experiment. You know the outcome of it. When you throw a die, you know the number is going to come from between 1 to 6 only, included 1 and 6. Right? Same, you toss a coin, fair coin, remember, not like that Sholay movie, right? So if you toss a coin, you know either it will be head or either it will be tail. Simple. We know the outcome, that what is going to happen, but we don't know exactly what is going to happen. So this is all about probabilities. So that is the experiment, right? Now let's come back to event one more time. Collection of some outcome of an experiment. Collection of some outcomes, only some outcomes, not all of them, right? You want number more than 3 on the dice, right? Then you are going to win the game, right? So that is collection of the outcome. Then you want 4, 5 and 6, right? That is the collection of an outcome. That's called an event, right? So experiment. Now experiment can be of two types: random, whose outcome you do not know, like we talk about the dice in the game of Ludo. You throw a dice and you don't know what number is going to come out. If you already know, you would have moved your player according to that number. You will not waste your time in throwing the dice and deciding that you already know about. Okay, so that is about the random experiment, whose outcome, whose result we do not know. And second is deterministic experiment, whose result we already know. Even if you try so many times, you know the result is going to happen this only. That is about the deterministic, means determine, whose outcome is already in front of you. Result you already know. That is the deterministic experiment. So these are the three basic ideas of this chapter. Now let's discuss types of probability. Now you must be thinking, I've never studied about the types of probability. You're wrong. You've studied in grade 9. If you're already aware of it, you've studied, great. You're doing great. Now, there are two kinds of probability, experimental and theoretical. Now, experimental means what? Experiment. You do experiment like science. Okay. You do experiment and you get some result and then you calculate the probability. Let's say you are tossing a coin. 1,000 times you toss a coin, 1,000 times you practically do in real life. There were guys who did this even more than 1,000 times. You can study in the books, right? Okay, so experimental. Let's come to this topic, experimental probability. We were at the point of tossing a coin 1,000 times. If you toss a coin 1,000 times and you notice every time, first time it was head, second time it was tails, then head, then tail, 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 tail. You keep note, you collect the information of that 1,000 results, right? You have a data of that result, that what is coming. Then you come to know that out of 1,000 times, 600 times head come and 400 times tails were there, right? So this is the experimental probability. You experimented, then you concluded the probability that 600 over 1,000, 400 over 1,000. You must have done these questions related to this in grade 9. It was there already, right? Next is theoretical probability. Now, theoretical probability, we all know that theory means what? We are only talking about theory. We don't focus on the practical life. So that's all about theoretical probability. We talk about theory. We have formula, we have some ideas, we apply the formula and we get the answer. So that is about the theoretical probability. We are going to focus on this concept more. This is also very easy. The formula is also given here, right? Like number of times event occur. Let's say a head occurs 600 times. So 600 in numerator. Total number of times experiment was performed. You perform 1,000 times. You toss the coin 1,000 times. So 600 over 1,000. That's your experimental probability. In case of theoretical, we cannot use that data, right? We want to imagine that if you toss a coin, either you will have a head or either you have a tail. So 1 by 2 is the probability. We have done this already, right? So this is a different kind of probability and we are going to focus more on this concept. Now let's discuss different types of events and some properties of the probability as well. Let's talk about different types of events. So far we discussed about probability, experiment and event. Now and formula, types of probability. Now let's talk about different types of events and its relation with the probability. The first is elementary event. It means that event with only one outcome. So whenever you talk about any kind of events, let's talk about the case of coin. Either you will get head or either you will get tail. So when we talk about the outcome of tail, let's say if we talk about the event of tail, there is only one outcome, right? Only one time it is coming. So that is elementary event. Next is equally likely event. Okay, equally likely. The word suggests that equally likely is going to happen. Equally going to happen. So if we talk the case of coin again, probability of head is 1 by 2 and probability of tail is also 1 by 2. So when you have probability equal, right? When you have equal probability and those events are called as equally likely events, probability of head and probability of tail, those are equally likely events. Next is sure event. Very important question. 1 mark it is being asked sometimes for MCQ as well. Event with probability 1 means probability is 1. Okay, 100% it is going to happen. Like sunrise in the morning, the probability is what? 1, right? 100%. We never doubt that next morning sun is going to rise or not. We are not going to doubt that. That is going to happen. Certainly it is going to happen. Surely it is going to happen. So that's why it is called sure events. Opposite to it, that is impossible event, which is not going to happen. Impossible, right? Don't go for I am possible over here. No logic there, right? Impossible event, right? Event with probability 0, whose probability is 0. That is the impossible event. Means that is not going to happen. Like sunset in the morning. Sunset, it's not going to happen in the morning. It happens in evening in a day, right? So that is the impossible event, not going to happen. Now, from these two events, sure events and the impossible events, we can conclude one thing, that probability of an event lies between 0 to 1. It can be 0, yes, for the impossible event. It can be 1 for the sure event. and any number between them is valid, right? This is a very common question, that which of the following cannot be the probability of an event, right? Sometimes it is written in the form of fraction, sometimes it is in the form of percentage as well. Remember, whatever you get, the answer should be between 0 and 1. Then only we can say that that can be the probability of any event. One more conclusion, that probability of any event cannot be less than 0. Less than 0 means what? It cannot be negative. Negative is not possible, remember, right? So whatever we discussed, this last 3 points are for 1 mark question. Remember, it can come just for the basic knowledge, right? It lies between 0 and 1. It can be 0 for impossible event, 1 for the sure event, right? And probability cannot be less than 0. It cannot be negative. It will always be positive. So this is about different types of event and how it is related with the probability. Now let's learn the next topic. Let's talk about one specific property of the probability, right? The sum of the probabilities of all elementary events of an experiment is 1. What does it mean? The sentence is little confusing, right? Sum of all the probabilities of elementary events, right, of an experiment is 1. So let's take an event of coin. So let's talk about coin. There are 2 outcomes here. Either you can have head or you can have tail. That's it. You are not going to have any third outcome over here. So if I want the probability of head, that is 1 by 2. How 1 by 2? Okay, so when you toss a coin, how many outcomes are possible? Head and tail. So 2 outcomes are possible. See carefully. का तो head आएगा या तो tail आएगा, and that will be in denominator, that is 2. But head कितनी बार आ रहा है उसमें? एक बार, right? So that will be in numerator. So 1 by 2, 1 time head is coming and 2 is the total number of outcome. Now let's do the same for the tail. So probability of tail, that will also be 1 by 2. Think why? Same case applies over tail. Now what we want to do with this elementary events probability, we need to do the sum of it. So if I add this probability, let's say probability of head plus probability of tail. So let's check it. 1 by 2 plus 1 by 2. So 2 by 2, that is 1. See, sum of the probability of elementary event is 1. We got the 1, right? Now don't write over here just 2 by 4. That's absolutely incorrect. This is just for the purpose of understanding. Nobody is going to ask you. Yes, 1 mark question can come based on this property. Now we are going to discuss few problems related to probability with case by case about bags, about dice, about cards, about coins, and miscellaneous problems as well. Let's start with those problems.